There are only red sweets and yellow sweets in the bag. There are n red sweets in the bag, and there are 8 yellow sweets in the bag. Therefore, straight away, I can work out the total number of sweets in the bag using algebra is simply n plus 8. Sergeant is going to take at random a sweet from the bag and eat it. After Sergeant has taken the first sweet from the bag and eaten it, he is going to take at random a second sweet from the bag. Well, as we're told he's eaten the first sweet, therefore we know this probability is without replacement. Given the probability that both sweets he takes will be red is 3/5, we're asked to work out the number of red sweets in the bag, and you must show all your working for 5 marks. Well, therefore, I need to work out the probability of getting red followed by red. I know the answer, in this case, is going to equal to 3/5. The probability of Sergeant getting red on his first pick is the number of red sweets in the bag originally, which in this case we know is n, that goes on the top, and it's always out to the total number of sweets in the bag, which in this case is n plus 8. In probability, we always know we multiply. For his second pick, again, we know he got red. As we know he ate the first sweet, therefore we know the denominator has to drop by 1, because there's 1 less sweet in the bag. So there's n plus 8 on his first pick, and his second pick is going to be out of n plus 7. We also know his first pick was red. If there was n red sweets to start with, we know there's 1 less red sweet in the bag. Therefore, his second pick, a red sweet, will be n minus 1. I know we're multiplying my first pick and my second pick. I'm told the probability, therefore, must equal to 3/5. As I've got a fraction multiplied by a fraction, I know we're multiplying fractions. I simply multiply the tops and multiply the bottoms separately. On the top, therefore, I've got n multiplied by, in single brackets, n minus 1. On the bottom, as you've got 2 terms, multiplied by 2 terms, I'm going to have what we call double brackets. And it's still equal to 3/5. Expanding out my single bracket on the top, I know whatever's directly outside, I multiply by each term directly inside. So n times n will give us n squared, and n times negative. Bottom, I've got double brackets. Expanding my double brackets, well, n times n, I know will give us n squared. N times positive 7 will give us plus 7n. 8 times 7 will give us plus 8n. Well, 7n add 8n will give us plus 15n. And 8 times 7 gives us 56. And it's still all equal to 3/5. As I've got a fraction equal to a fraction, I can apply a method called cross multiplication. The opposite divide is to multiply. Likewise, the opposite divide by 5 on the right is to multiply up 5 in the numerator on the left. Hence, on the left-hand side, I'm going to have 5, lots of single brackets, n squared minus n. And on the right-hand side, I'm going to have 3 lots multiplied by n squared plus 15n plus 56. Multiplying up my single bracket, on the left-hand side, 5 times n squared will give us 5n squared, and 5 times negative n will give us negative 5n. On the right-hand side, expanding my single bracket, 3 times n squared will give us 3n squared, 3 times 15 will give us plus 45n, and 3 times 56 will give us plus 168. I can now see I'm getting a quadratic in terms of n. As I've got more positive n squared on the left, as I got 5n squared, and I've only got positive 3n squared on the right, I'm going to bring everything from the right across the left by doing the inverse. Hence, the opposite of add 3n squared is do the inverse, and that would be to subtract 3n squared from both sides. Opposite of add 45n, which is the inverse, and that's subtract 45n from both sides. Opposite add 168 will be to subtract 168 from both sides. On the right-hand side, I know everything's going to cancel. That's the whole purpose. And that's going to leave me with 0. And on the left-hand side, collecting like terms, I've got 5n squared take away 3n squared, which will simplify to give us 2n squared. Negative 5n take away 45n will simplify to give us negative 50n. And I've still got the negative 168 that came across. I've now got a quadratic in terms of n. As I'm solving it, I can see that all 3 terms are a multiple of 2. They're all even. So I can divide all 3 terms by 2, and it does not affect my solution. 2n squared divided by 2 will leave us with n squared. Negative 50n divided by 2 will give us negative 25n. And negative 168 divided by 2 will give us negative 84. As we're solving a quadratic, and we've got 3 terms, I'm going to factorize it. As it starts n squared, I know each bracket must start with a single n. I now need to find 2 numbers that when multiplied together give us our constant, our number term, in this case negative 84, and the same 2 numbers must still add to give us the value in front of the single letter, which in this case is a single letter of n, which in this case is negative 25. As my constant is negative, I know I must have 1 positive and 1 negative. That's the only way to get a negative number, negative constant. In this case, my 2 numbers will be plus 3 and minus 28. I'm now solving each bracket, so I'm going to put each bracket equal to 0. On the left-hand side, if I put n plus 3 equal to 0, opposite of plus 3 will be subtract 3 from both sides. So one solution is n equals negative 3. Put my second single bracket equal to 0. Opposite of minus 28 is to add 28 to both sides. So therefore my second solution is n equals 28. When you solve a quadratic, you will always end up with two solutions. But in this case, n cannot equal to negative 3, as you can't have a negative number of red sweets. Therefore, in this case, n is equal to 28. Therefore, number of red sweets, in this case, is 28.